Hello everyone, this is Alfia Sando. Today I'm going to share my experience to install PySpark on both two platforms, Google Colab and Ubuntu. So if you don't have Ubuntu systems, you can follow my tutorials on Google Colab, and who cannot access to Google Colab, especially Bilibili audience, you can choose to install it in Ubuntu. Also, I'm going to showcase to solve a toy example of word count, use the install PySpark. This video is also the preparation for my MapReduce design pattern series. So in the future series videos, I'm going to pick some standard examples from this book, then to expand how we implement the different patterns for MapReduce. So please stay tuned, and there's exciting topics coming. If you want to learn more about MapReduce fundamental, and you also want to check the ideas to solve the word count, which is help to understand these videos, please check my previous video, hack rank MapReduce word counts. It shows at right upper corner. Okay, then let's go first to learn how to install PySpark in Google Colab.
Hello everyone. Let me show you first how we install Spark in Google Collaboration, and we'll also run a toy example for word count. So first, to open a notebook in Google Collaboration, then we install Java, and we download the Spark package from the website and unzip that, then also install PySpark. You don't need to hurry to write down all the commands here. I will record all the commands and pasting on my blog, so you can find the link of my blog under the video. Another thing to be noted that the link of the Spark package will be changed a long time. So say if you find these videos after 6 months, you might need to change the HTTP link here from the Spark official website. Now we have installed Spark and Java. So we also need to configure our environment to let the Google Collaboration find the Spark address properly. So now the system has already found the Spark, so that we can enter our toy examples. First, we import the Spark session. Then from the Spark session, we build a session that uses a simple configuration temporarily. The master local here means we want to have a sessions using single long node and has Colab as name, and just create it. You can also try different fancy configuration. For example, to have a session to use multiple node resource, or have a Spark graphic UI to show like how is the different node runnings situation. Here I'm more focused on the implementation and the algorithms level, so I just make it simple. Next, we transfer our input list into the Spark data container. They call it RDD. Then we call spark.context.parallels. So ideally, if you have multiple nodes, it will boost our transformation speed to the RTD. So now we have RDD, which save all of our input example. So this input example is a similar one in my word count video. Then what we want to do is doing the map operation first. The map operation in Spark is implemented by rdd.map function. Then it's coming a lambda function in Python. So this lambda function told us for each elements we want to generate a pair which key is the element and its value is 1. So Spark is running in a laziness way. We only have to call collect, then it will be generate the new RDD. So after we create a new RDD for map result, we have to print it with a collect function call. So here, for each key, we have one associated with it. So we have 5 pairs. Only difference with the input list, we just have convert one element into a pair. So next, we want to implement our reduce operation. So basically, the reduce by key operation for RDD is for each same key, we want to aggregate its value. So x and y is like 2 values, right, for same key. For example, for the first one and the third one, it has same key. So here we will combine those two and aggregate the value of that. Then the same for dog. For dog has same key and we aggregate its value. And the big and dick cannot find the same key, so we don't do any operation. So we'll generate RDD of the reduce. Then we print what it looks like. Yeah, so this is exactly we want. And after map and the reduce process, we are successfully finish our requirements for the word count. So next I'm going to talk to how to install Spark in Ubuntu system and run a talk example for word count. So if you cannot access to Google collaboration, especially for Bilibili audience, so you can choose to install Spark in your Ubuntu environment. So the prerequisite for this tutorial is to install Conda. So here you can see the terminal below my idea here. I'm in a random environment at the Conda. You can also start with random environment. So what you need to do is to create a new environment, give it a name, and ask it install Java and install the Spark. So proceed. Since it will take a while, let me explain. Oh, actually, it's running very quick. So after we create an environment, we can directly go into that new created environment. Okay, so here it shows right now we are already in that environment. So yeah, basically we are almost finished the whole tutorial. We successfully installed the Spark. So then let's go through the talk example of word count. So what we do is we create a new Python file, then import PySpark session. So then that means we build a session with our given configuration. Here I'm using mouse as local, which means it's a standalone session. Maybe it might only use one node, not really exactly doing the paralleling. Then given the app as Colab, and the get or create will find an existing session, or if no, then create a new one. Feel free to try more fancy configuration. You can try using multiple node in your system, or you can also have a server was building on based on the local machine. So here I more focus on the algorithm side and implementation. So I try to keep it simple. So after you get a session, then you get its context, then you call parallel, basically to put this input as work example, transfer it to Spark data container, so-called RDD. Then I'm assuming if you have parallel node set up, so it will parallel reading the list. If you cannot remember how we did this word count examples previously, feel free to jump back my previous word count example. So in that example, first step we'll do map. So basically for each elements in the list, we extend these elements into a pair. Then the first value in pair is still is key, and the second value is 1, which means it's count once. Then the Spark has this kind of laziness mechanism, so when we generate new RDD, it won't successfully generate the data first. We need to call collect to generate. So I will print this afterwards. You can see what our map produced. Then second step is to reduce. So in Spark, it's called reduce by key. Then we put another Python lambda here, and please note that so xy means here, which means all the second value of pairs, but xy should all come from the same key, right? So for example, first cat have a pair, and third cat has a pair. Right now, x and y are all ones related to each pair. Then here, what we do is to append them together. If the list has 3 keys, it will append recursively. Then the key is still the same, right? Then again, after we run our reduce operation, we'll call collect for the new RDD and generate a final example. Then, since we are already in the Spark environment, we can directly run this Python file. Okay, so you can see first line printing out is our first mapping examples, exactly given for each element, extend the pair of that, given the value as 1. Then for the second line here, it's a reduced result. It basically is find 2 keys from different pairs and trying to append them together, 1 plus 1 equal to 2, and the same for dog. Okay, so this is the Ubuntu tutorial. You don't need to write all the commands to install that. I will record them and put in my blog. You can find my blog in below, and all the talk example for word count you also can find there. That's all, and thanks for watching this video. See you next time.